lesson 6 was the last difficult lesson. The last few lessons are easier, so that's good news. Okay. Okay. You got this?
No. Transformer.
Yeah. I'm just wondering, are those your pajamas or?
No.
Are you sure? Because it looks like you just came out of bed to come here. Are you sure?
Yeah. I mean, it could be.
You could be honest. We're all friends here. If you want to come to class in your pajamas, that's no problem to me.
Get clothes, not to the
Okay, all right.
Shirt is from
Toy Story.
Yeah.
Yeah, Toy Story.
Yes.
Yeah, look.
Buzz Aldrin. Okay, you got this, Transformers?
Cool.
Okay. Right. So in this lecture we will study Transformers. Here's an example of a Transformer. This is Optimus Prime. He fights the Decepticons, like Megatron. Oh no, wait, no, that's not what we're doing. Not that Transformer, but this Transformer. So actually this is what, it's not as cool, I know, but this is what a Transformer looks like. So let me just explain the picture. So all a Transformer is in physics is you have a piece of iron and you have a wire that's wrapped around it this way, and then there's another wire wrapped around this way. So there's just it's simple, it's 3 parts. Part 1 is the iron, part 2 is this wire, and part 3 is this wire. Okay? And this one is called the primary, and this one is called the secondary.
No.
Yes. You sure? Now you don't need all the details. All I care about is this, and this wire, and this wire. And this is called the primary, and this is called the secondary.
How do you know which is the primary, which is the secondary?
The primary is the voltage you start with. I'll explain what it does in a minute. Actually, you know what? We'll come back to the picture in a minute. Let me explain what it does. We'll draw it in a minute. No, we can draw this in a minute. I just want to say what a transformer does. So you all have a transformer, actually. I think that's one there, maybe, or well, here's definitely one here. This is a transformer here. If you got your phone charger, you know the plug is usually bigger. A transformer, it's an electrical device, and its job is to basically, and there's a long explanation, but basically it's to change the voltage. Now I think that explanation is maybe too long. Too long. So I'll give you a simpler one. No, it's not working. I'll explain what it is, and you can write some of this down. I'll tell you which part to write down. Really, it's the last part. Commonly, transformers are used to increase or decrease the voltage of an AC. So, for example, this here is 220 volts, but my laptop, I think, only needs like 6 or 12 volts. So the transformer takes 220 and changes it into 6. Okay, so like your phone, I think your phone is maybe 3 volts. So the transformer on your phone takes 220 and converts it into 3. So transformers changes the voltage, that's what it does. So can you just write the last sentence? resistance down. This is what they do. Yes?
Program is the subject.
Here?
No, here.
Program, the subject, yeah. What you want to study.
BA in internal design.
Okay.
Is this a real name?
I'm sure it is.
What is BA?
Bachelor of Arts.
Ah,
It's the type of degree. BA is arts. BSc is science. What's engineering? BEng is engineering.
wow, very long.
Yes, yeah. Okay, did you write that sentence down? Yeah. So there are two types of transformers, a step-up transformer which increases the voltage and a step-down transformer which decreases the voltage. So please write these words down, step up and step down. Yes? Did you write down step up and step down?
What is that?
Oh my goodness, step up increases the voltage and step down decreases the voltage. Very good.
Oh, that is right.
Yeah, and it's right there as well. Okay, continue. Okay, so I think we can draw it now. So you can draw this now. It'd be great if you can write everything, if you can draw everything, but let me just highlight the important part. So this is called the primary voltage. It's the voltage that goes in. So for example here, the primary voltage is 220. And this one here is what comes out, and this is called the secondary voltage, and in this example, this would be like 12. So there's a piece of iron, and the primary wraps around on this side, and the secondary wraps around on this side. Okay. So if you draw this, I'll explain how it works after you draw it. Okay. So please try to draw this nicely. Yeah?
So that's one. It's more than that.
If it's stepped down, this is more than this.
The step up?
This is more than this. So this picture here is step down. More here, less here. In your home, do you think most are step up or most are step down? Step down in your home.
Why?
Because usually you want to decrease the voltage for your computer, your phone, your laptop.
To save money?
Not to save money actually.
To save?
Not to save anything. The laptop is very sensitive. The parts are very delicate. They need a low voltage. If the voltage is too big, it will get too hot and it will burn. Washing machine can run at 220. It doesn't need a transformer. Some things don't need a transformer, like light bulb, washing machine, TV. They all use 220. It's usually, Andy, it's usually electronics like iPad, laptop, phone, maybe even a games console. Anything that has electronics in it requires a low voltage, like 3, 4, 5, or 6 volts. Great, switches at step up or step down in this
Step down.
Step down, yeah. Okay. Can I explain how it works? Did you draw it? No? Okay. To try. No. Wrong picture. Totally wrong picture. No. No. Yes. Zoom in. It's okay? NP, yeah. NP, I'll explain in a minute. Yeah, turns. How many turns? Okay. But the video would be better, maybe. You can watch it on the video if you. Okay, can I explain? Oh my goodness! I want to explain how this works. Oh, you too, and you too. Okay, never mind. Okay. Let me explain how this works now. I'll keep the picture up there, but I'll explain how it works. Okay. So, remember you have your right hand grip rule. So, the current is coming along this way, and you have your right hand grip. So there's a magnetic field going around this. So if you remember, this is called a solenoid. Do you remember that? You have the current, and it makes a magnetic field around the current. Yeah? Now, if this is alternating, will the direction stay like this, to the right? No, what will happen? It'll turn to the left. So what will happen to the magnetic field here? It changes. So the magnetic field here is changing back and forth. It's going up and down, up and down. Yeah, the current is changing. So every time the current changes,
If you mention your own, just change.
just alternating current, just change it. Remember the graph, the current, up, down, up, down, up, down.
Like AC?
Like it is AC, yeah, yeah. So this is AC. So because it's AC, the magnet here is going backwards and forwards. So this magnet here, it reaches to here. But if this is changing, then you get a current here. From the homework, you can use the formula to calculate the current here, the induced current. Because you have a magnet, and then what happens? The magnet changes. So then what do you get here? You get a current. So if the magnet keeps changing here, then it makes a current here. Now, if you think about your formula, you have voltage equals N times delta phi over delta T. And here you have voltage equals N times delta phi over delta T. Okay? So in this case, the voltage is the voltage that goes in. So can you write this down? V1 equals V1 equals minus N1 and then delta phi over delta T. And then over here, this is V1, the voltage here. And then over here, V2 equals minus N2 delta phi over delta T. So what I want you to do for me is cancel the delta phi over delta T. I want you to put those formulas together to make a new formula. So I want you to combine these. Yeah. So cancel these. You could divide them or whatever. Tell me what formula you get. Yeah, you could just divide them. No. Huh? Yeah, N1 over N2, yeah.
Yeah. Okay, it becomes V1 over V2 equals minus N1, I mean M1 over N2.
Yeah, so you should get this formula.
Where did the N come from?
What do you mean, where does the N come from? N1 over N2. Huh?
Oh, I thought you said M.
No, N.
Okay.
Did you get this formula? Yeah. So the V1 is the voltage that goes in. V2 is the voltage that comes out. N1 is the turns on the primary, and N2 is the turns on the secondary.
Oh, what did you say again? V1 is
Oh, dude. V1 is the voltage going in on the primary, and V2 is the voltage coming out on the secondary. N1 is the turns on the primary, and N2 is the turns on the secondary.
Yeah.
So this is the formula for transformers. If you know the voltage going in and the voltage going out, then you can calculate what the N2 is if you know the N1. Another important thing about transformers. Continue. The energy is conserved. So the power that goes in must equal the power that goes out. Now that's important, okay? Look. Do you remember the formula for power? What's the formula for power? P equals...
Work done over time.
Yeah, well, using current and voltage and things.
No.
P equals IB.
I.
Yeah. So, in this example, is the V getting bigger or smaller? It's getting smaller. So that means the I must get bigger because the power still stays balanced. So the power that goes in must equal the power that comes out. So the power in still equals the power out. So you can't use a transformer to make more power. The current ends up changing. So you could say I1 V1 equals I2 V2 if you wanted to as well. Here you could say I1 V1 equals I2 V2. And if you make the voltage bigger, what would happen to the current? No, smaller.
Smaller.
Okay, continue.
What is the string name?
Oh yes, you missed this. Does anybody remember? Can anyone tell Andy what this is? If you remember from semester 1, efficiency. Efficiency. Okay. You can get that from somebody after class. So you could put this formula together with this formula and make this one. Well, I'll read it to you. N1 over N2 equals I2 over I1. And if you want to know how I got that, I used this one and this one together. So those are the 3 formulas you need for transformers. Yes. Question? No. Example now? Continue. It's N1 over N2 equals I2 over I1. Are you talking to Amanda?
No. I'm searching Google.
For what? Amanda?
No.
Continue?
Yes.
Yeah. Okay, so let's have a look at an example. So, a small toy, like a Game Boy, needs 6 volts. It gets 220 from the main supply. The number of turns on the primary is 4,400. How many turns are on the secondary? I want you to try this. I don't think it's very difficult. You need to use the first formula I gave you. Okay, got an answer or still writing? Grace, what are you doing? Are you doing this one?
No.
Try it. What's V1?
210.
V2? N1?
400.
4, yeah, 4. So give me N2.
150.
You got 120?
Oh, one.
Which one?
No.
V1 is 220. V2 is 6. N1 is 4,400. And N2 is what I want. Did you get an answer?
110.
You got 120 as well, okay. Did you? 120? And we'll get Grace to confirm as well. 120. Yeah, and that's it. So, I mean, I only needed to do one example with you because it's simple formula. This is the homework. Yeah? Yeah? Okay. Let me just fix something before you go. I'll let you go in one moment. I just want to talk to you first about your lab report. What's wrong? Say again? Do I know your UCAS number? I do not know.
Do you know how to check?
No, I do not know how to check.
Maybe.
No.
Maybe you're gonna mail from.
Oh, that is, you have to go on the college website.
Okay, so before you go, what? Wait, oh, slow down. Before you go, I want to know where you are with your labs, Kareem.
I'm done with the lab book. I just don't have the conclusion yet, and I've done a quarter of the the type.
A quarter? Okay.
Yeah.
Where are you, Sophie? Worse than him, yeah? Okay, great. And Andy, you have one type report. And Grace? The type report is half? Everybody has the lab book finished, right? Yeah?
Almost.
Oh, dude.
I think the conclusion and the
I'm forgetting about you for a moment.
Lab
The lab book, yeah. You have the lab book finished? Do you? Okay. Can on Monday we have class? Yeah. Can you bring your laptop and your lab book? And we will look at what you did. I want to make sure it's okay. You're going very slow on this. Do you have other things you're doing? What?
So many.
So many things. What else?
Math, chemistry, AV.
And all of these things are more important than physics?
No, equally important.
The deadline is more closer.
Yes. Okay, well, we work on the lab reports a little bit on Monday in class. Yeah? Can you bring your laptop and your lab book? I want to see what you wrote. Make me happy, yeah? Yeah. Alright. So long. We'll finish there. So on Monday, don't forget, please, your laptop and your logbook.